So hello everyone. As Jim said, I'm Renan. I work here at Wildlife Studios, a mobile game company, and I've been here for almost 5 years now. So I had the time to work in some very nice projects. So in this presentation, I'll talk about like a better game experience with machine learning and the Hopsworks Feature Store. So the idea of this talk is to briefly comment on our history of the company, especially through the lens of machine learning, how machine learning started happening inside the company, how we evolved over time, and how we end up right now having a feature store that is basically the core of the platform that we are building, and talk about how things happened, maybe the main learnings that we had, and the things that we hope to have the time to work on. Okay, so Wildlife mission is to build the games that are going to impact a generation. So we really want to make those games that like in 20, 30, 40 years from now, people are going to talk about. Because like we as kids and even now, we love games, and we have some very iconic games and characters that really made a mark on ourselves in our lives. And we want to be the ones that do this for the next generation. So we really want our games to be engaging, fun, and feel amazing to play with. So we want to have fun while giving people fun as well. So so far, we've been the pleasure to build some very nice games. So we have Tennis Clash on the left. It's basically a tennis game. The gameplay is amazing, and the graphics are awesome, especially for a mobile game. So it's nice to see that mobile phones now have a lot of power, processing power, to enable us to have such beautiful games. But it's not only about making the games itself, because like people needs to discover our games, to know about them and wanting to play them. So it's really important for us to make our games stand in this countless seas of options, because like when you enter a store on a cell phone, you see like 100,000 games available. So we need to shine among them and appear to the user, and want the user to have the chance to engage in our games and have fun. So it's really important for us to attract people, to make them to know what we are up to, and having them fun and engaging with our games. So this is essential. And this is where machine learning shines. Our role as a machine learning engineer is to help make more smarter decisions. So instead of only relying on human knowledge, past experience, and some analysis, we also want to provide to provide models that help us getting more insights from our data and help us to take better decisions and be more effective in our job. So we really have the opportunity to work with a lot of data. So data is really our fuel to decide which features to include in the game, how to promote a game, which characters would be best to use, which items a player may want to equip in a character. So data is really essential for us. And machine learning models are just a natural choice, and I could say even a necessity, given the volume of data and the number of users that we have. Right now we have more than 2 billion downloads. So we have a lot of people playing our games. So we need to make sure that we know about their interests and move the games in a direction that is best for everybody. So machine learning started as like individual efforts. So some teams like trying to predict revenue, trying to decide which marketing campaigns would be the most effective, how to make some changes in the games. They started individually, like in small teams, applying, creating models and applying machine learning. And at that time, data engineers were the go-to option for data scientists. So anytime that they needed some time of automation and improvement and configuration of clusters to install training libraries and so on, we were the ones that would make things happen. But over time, we needed to specialize. The demand was growing the size of the data sets was also including. I remember that some years ago, people used to download CSV files to train models locally, but at the time they would spend like the whole day just downloading them. So we knew at that time that we needed to create this environment, but like on the cloud, people would experiment with data and train models. So, and those demands were much more broader than our previous scope, the only data engineer, data pipelines. So we needed more knowledge about cloud infrastructure and so on. So that's where, and also about like training the models and specifics of dealing with machine learning models. That's why that's where machine learning engineers enter the stage. We needed people with more experience and more focused in helping data scientists to make great work. So we basically brought a lot of knowledge about software engineering, infrastructure, cloud, how to create pipelines and so on. So data scientists could be more effective in their work. I will try to make some simplification here, because like data scientists and machine learning engineers have different roles at different companies. And I know that simplifications are dangerous, but to give a glimpse of how we divide ourselves inside the company, data scientists are usually responsible for modeling and analysis. And we, machine learning engineers, we focus on scalability and efficiency. So we are the ones that bring the knowledge about like pipelines and code versioning and good practices of software engineering that helps data scientists to be more efficient in the long run. So I think that's a good way of understanding the way that we work inside the company. But of course, even having machine learning engineers embedded in those squads is not enough. Separated teams sometimes repeat the same problem more than once. So some teams were developing solutions to deploy models, other teams to store and make data available for models in production. So we needed a way to get this knowledge that was being built inside each team to flow across the company. So we needed to scale our approach to machine learning, like, and really tackle this as a more like company level effort, not only project by project. So we decided to assemble a team that would focus on advancing machine learning inside the company as a whole. But it's important to notice important context of what is happening inside the companies at the engineering level. We have been focusing a lot in the last quarters on governance and developer experience. So we not only need to provide those functionalities for data science, we also need to make it in a way that is scalable, because the company is growing fast. Like when I entered the company like 5 years ago, we had a few more than 100 people working there. Right now we have almost 1,000. So there's much more people using data and training models. So we need to make this very conscious about like which resources are be using, what data is stored, where the artifacts and code and pipelines, they relate to each other. So we need to be very strategic here and take this into consideration. And also we believe that best practice and standards should be spread and sometimes even enforced using technology, like giving a checklist or like a long documentation for people just to know what they need to, some guidelines and restrictions that they have. It's not very efficient. If you can embed those in technology and leave people only focusing on their job and those other requirements being done automatically, this can really make them more productive. So we really believe that technology is the thing to make our work much better. So that's where a team, like almost 1 year ago, we assembled a team that we call internal machine learning apps team. So this team is responsible for building the products that are going to be used by those different squads. So each squad has their own tech stack, their own products, their own requirements. Some use online serving, some use offline serving. Some of them have really low latency requirement because they work with online advertisement. Others build models to be used inside the game, like during the menus and so on. So they they can afford to take their response back like 1 second later. But for advertisement, this is unfeasible. So even though they have these different requirements, there are a set of entities, components, and ideas that is common among all of them. So our team wants to leverage on that and build things to help the teams to focus on their business specific requirements and let this automation work for us. So that's why we build this team with people with different backgrounds. I worked some years as a data engineer, both as a data pipeline engineer and later as a data platform engineer, like taking care of the clusters and scalability and so on. We also have people with a lot of experience with SRE, like everything related to DevOps and this kind of automation, monitoring, alerting, and so on, to make the system really reliable and robust. And of course, people with experience with machine learning, both building pipeline and also modeling. So dealing with data, feature engineering, training models, hyperparameter optimization. So these people with those different backgrounds, they really have been working well together. And we are developing those tools to enable the teams, basically to make for them easier to have machine learning pipelines, not only having a way of training and monitoring models, but also a consistent way of deploying the whole pipeline and make improvements on top of it. So we took as a foundation, Backstage is a open source project from Spotify. So this platform is being used by the whole company to build products that help developers to build their projects. In our case, we're helping developers to build features and also machine learning pipelines, but also building meta games, Go applications, and so on. And on top of this platform, we are building our projects powered by a lot of different tools, because we have machine learning is very complex, so we need a lot of specialization. So we are leveraging Hopsworks as our feature store, MLflow to be this central hub of metadata management. So everything related to experiment, a model that has been trained. So all the parameters, configurations, and metrics and artifacts are also unified under MLflow. GitLab is our source control. Databricks is where we do all related to data processing, also model training. Apache Atlas is our main catalog for data. So any data that you use inside the company, any feature that you be using our pipelines is going to be saved on Atlas. So it's going to be easier to find features, reuse features, and help the company to grow. Airflow is the tool to manage the pipelines. Our models, there are served. Some people have this online serving use case, so they serve models using Flask APIs on top of Kubernetes, and also we use Scheduler to organize our data science project. So the feature store is basically the heart of MLOps. Data is everywhere. Every step is basically you can like make the simplification and assume this is basically a data transformation. So we needed something that would unify the consumption of data, so we could have stronger guarantees for data scientists, like the same data can be available in both streaming and batch ways of consuming data, and also tackling this training serving skill. That is a big problem, because some teams suffer a bit of making this data available in those two steps. So sometimes some inconsistencies can arrive. So tackling this as a more systematic way was very important for us. And about the way that we use Hopsworks, as you can see here, like Hopsworks is the center of the operation that we do regarding features. I already explained a little bit about how to use those tools, but I can add here that this system, since this feature store, we had a very nice integration of Hopsworks with our ecosystem. We already previously have tools for a lot of steps, so Airflow, Atlas, and so on. They were already there. So we needed a system that would connect everything and make it easier for us to have this data available. And since what we want to focus in our platform is to enable developers to do their job in a very easy way with a very curated developer experience, have very strong governance guarantees, we needed, was like almost sure from the beginning that we needed a feature that was mature enough to be reliable and be the base of our work, and so giving us time to build the more high-level features that we needed for our company. So also the great performance of online serving, like getting the features with very low latency for model serving, was very key for us. And of course, like the way that they charge us about like the use of infrastructure instead of, for instance, number of requests, really made it easier for us to support our use cases because of the size of our user base. We have tons of requests, so this was a very nice thing for us. Talking a little bit more about the feature. Besides, like now that we are building this platform and we are having these components well integrated, we are going to need to tackle more high-level problems that comes from building those very well-defined interface and functionalities. We need to learn how to better optimize the resource usage. We have tons of data, we have basically two big ways where we store data, like our data lake, that this has some petabytes of data, some dozen of them. And now the feature store that is rising from the platform that we are building. So we have a lot of data. And so when people train models, they train sometimes like months and months of data to train models. So it is really important for us how to optimize this. So right now we are handling this for the user to decide which is the best configuration that they can use. But of course, they want to get the initiatives moving. So it's important for us in a systematic way to tackle this problem and let them focus on the business specific problems, not those more general ones that we can tackle as a central entity. We want to get to the next level of CI/CD. So we want to have this problem of creating a pipeline being transformed in a more way of continuous integration, continuous delivery. So how, instead of thinking about the whole pipeline, you can start thinking about changes in the previous pipeline and have this trigger everything. This is going to be a very nice improvement that we are going to be working hopefully very soon. And how to scale model performance monitoring, because like a model is a very complex entity, because like especially being served as a service, you need to monitor infrastructure, the service level of the API, the responsiveness, and so on. And also the business side of it. We need to find a way to very well connect our main flow of data with the flow of data from the models, the predictions that they do, in a way that it's just easy to get a new model up and running and also monitoring its performance. So this is going to boost a lot the way that we experiment with models. And of course, to do all this, we need help. So people are enthusiastic about this challenge. Of course, we are hiring. We have a lot of very dedicated people that would love to have extra help working on this. So I think that's it. Thank you very much.